The world population never stops increasing, and people use more and more energy. The Earth is on the edge of breaking down. We deplete its resources without counting. We must find another way to create the energy we need if we continue to consume it so fast. The solution to that problem surrounds us. We only have to look up in the sky to see what has fascinated the humans for so long. The sun. Less than 1% of the solar energy that gets to the Earth would be sufficient for the planet's annual need. And unlike the fossil's energy, this one is inexhaustible.
Hello and welcome on Green Days. I'm Fanny and here's Quentin. As we just saw, solar energy is non-negligible.
Today we will learn a bit more about solar energy. But let's see first how photovoltaic effect works with Professor Guillaume.
So, how does a PV cell work? To understand it, we first need the concept of light absorption by solids.
In a semiconductor crystal, the valence band with the electrons is separated by the conducting band of energy difference Eg. When a photon with enough energy reaches an electron, the electron can jump to the conducting band, but he is going to slide back down and lose his energy by emitting a new photon.
To avoid this loss of energy, we need to introduce a second concept, the p-n junction.
In a silicon crystal, the electrons can hardly reach the conducting band, so we are doping the solid with bore to create an acceptor level, or with phosphor to create a donor level in order to increase the conductivity of the semiconductor. By uniting these two concepts, we create the p-n junction. The donor level electrons will migrate to the acceptor level and so create a potential who acts on the electrons.
Finally, it is the combination of these two phenomena that provide electric voltage and currents when the p-n junction is exposed to sunlight.
In a PV cell, when a photon reaches an electron-hole pair is created. But because of the potential difference, the electron will not slide back down and we experience the apparition of a current I.
Thank you, Professor Guillaume, for those explanations.
Even though silicium panels are the most used today, there are different technologies. One of those are the organic cells, which we are going to explain right now.
An organic solar cell is a type of polymer solar cell that uses organic electronics, a branch of electronics that deals with conductive organic polymers for light absorption and charge transport to produce electricity from sunlight by the photovoltaic effect. Compared to silicon-based devices, polymer solar cells are lightweight, potentially disposable, and inexpensive to fabricate, flexible and customizable on the molecular level, and they have lower potential for negative environmental impact. Also on the market, the silicon concurrent doesn't exist. Organic solar cell seems perfect, but their disadvantages are also serious. They offer about 1/3 of the efficiency of inorganic devices, and they are relatively unstable toward photochemical degradation. But let us now look into an organic solar cell. When a photon arrives, the electrons in the highest occupied molecular orbital, HOMO, receive energy. The transition from the HOMO to the LUMO, lowest unoccupied molecular orbital, leads to the appearance of a hole that is stay-bound with the electrons by electrostatic interactions, so we call the electron-hole pair an exciton. Excitons are broken up into 3 electron-hole pairs by effective fields. The effective fields are set up by creating an heterojunction between 2 dissimilar materials. Then they break up excitons by causing the electron to fall from the conduction band of the absorber to the conduction band of the acceptor molecule. But it's necessary that the acceptor molecule has a conduction band that is lower than that of the absorber material.
We are lucky to have with us today a businessman who will describe his application of the organic cells. So please, let us introduce yourself and your ideas.
Hello, so I'm Noé from SolarTrek, and first I'm wondering if some people watching often meet situations where energy is hardly reachable. If you do, you might be a habitual climber or hiker who goes on his way for several days. In such conditions, there might be several things annoying you, or worse, getting you in trouble.
Could you tell us some examples?
Of course. Your camera having a flat battery plumb in the middle of your trip, or a useless torch when the night arrives. The lack of energy can be a real issue, and that is the point where we come in.
Let us now watch a testimony of Emil, an hiker.
I love to escape from the city and go trekking in the nature every once in a while for a week or two. Not so long ago, I always had to make sure my phone was charged, and if the battery was down, to quickly find a house to charge it. If a problem occurred, I needed my phone ready to make a call, but that was before. And now I have the Solar Trek, which is a backpack with a solar panel integrated, so I can have all the energy I want to charge my battery. If I don't use it or if there is no sun, I can put it in a pocket, and it takes no energy, no place at all. Now I can seriously consider realizing my dream, which is to go skiing on the Antarctica for a month.
So now that we've seen a concrete application of organic cells, Noé, can you tell us more why exactly are you here today?
Yeah, for sure. Well, I'm here to find investors, or at least try to get their attention. And therefore I will not let Dylan introduce the financial part that will probably interest them for sure.
Hello, I'm here to give you an outlook of the profitability of this business.
This first graph shows the profitability of the 36 first months. We reach break-even point at the 13th month. We can see the total cash flow for the same period, and as you can see, we start making true profit after 2 years, and estimate it of almost 200,000 € after 3 years. Our theoretical prevision gives us a maximum gap of about 55,000 €. At the margin, we are now looking for an investor for 75,000 € that would be greatly compensated with the added value that comes with it.
We shall now conclude. Do you have any last words?
Yes. Well, if you feel interested in a business and if you feel ready to invest in a project, I hope you will give it a try.
So thank you, Noé. However, organic cells have still a long way to go, but we do hope that in a few years it will be present everywhere. Thank you for your attention and
See you next week.